In the previous movie, I invited you to analyze data using the normal, Poisson, and exponential distributions. In this movie, I will show you one way to approach these problems. I'm in Chapter 4 Challenge, and you can find that in the Chapter 4 folder of the exercise files collection. I'm on the normal worksheet, and I want to work with data that is normally distributed. And in column B, you see that I have a mean or average of 145 and a standard deviation of 35. In cell E3, I will calculate the percent of values that are less than 119. So in other words, about one standard deviation below the mean. So in E3, I'll type equal norm.dist, because we're working with the normal distribution. Our comparison value is 119, then a comma. The mean is in B3. Standard deviation is in B4. You can see those highlighted over on the left, then a comma. And I do want to work with the cumulative distribution. So I'm looking for all the values below 119, not the point probability of getting 119 randomly. So I'll do true, right parentheses and enter, and I get 23%. So a little bit less than a quarter of all values in this distribution are less than 119. Now we can do a similar calculation for percent of values greater than 185, except we need to subtract the value from 1, because instead of looking to the left of the value, less than, we're looking to the right. So for E4, type equal, 1 minus, and then a very similar calculation to what we had before. Norm.dist, 185, comma, means in B3, standard deviations in B4. Again, looking for the cumulative, right parentheses, enter, and we get 13%. That's good. So we've accounted for 36% of our values. Now we can calculate the percent of values between 119 and 185. So I'll type an equal sign. To perform this calculation, we need to find the number of values that are less than 185 and subtract the number of values or percent of values that are less than 119. So I will type norm.dist, and then we'll use the higher number first. So that's 185, B3 for the mean, B4 for the standard deviation, comma, and then true, right parentheses, and then minus the same calculation for 119. So 119, B3, B4, true, right parentheses, and enter, and we get 64%. And one way you can check your work if you're doing this type of calculation is to press Alt equal, which creates an AutoSum formula, and enter, and we get 100%, so all of the values are accounted for. We can also use norm.inv, or the inverse norm function, to find the cutoff where a certain percentage of values are below that cutoff. In this case, we'll look for 42%. So in cell E8, I'll type equal norm.inv. The probability is 42%, then a comma, the mean B3, standard deviation B4. Don't need anything else. Right parentheses, enter, and I get 137.93. And that makes sense. It's not that far below the average. If we want to calculate the cutoff for 18% of values above a particular value, in other words, 82% or below, in cell E9 equal, and then norm.inv. And here we want to subtract the probability from 1. So instead of subtracting this entire formula from 1, we want to subtract the probability from 1 so we get numbers to the right of the cutoff. So 1 minus 18%, comma, mean B3, standard deviation B4, right parentheses, enter, and 177.04, which is almost one standard deviation above the mean, and that does make sense. Right, that's the normal distribution. Now let's switch over to the exponential and Poisson worksheet. And from here, we have our worksheet that calculates customer arrivals and the amount of time the service takes, the time the service starts, and when the service is complete, plus any wait time. And the key to this worksheet is to define probability curves for the Poisson and exponential distributions. So we have a lambda of 8 for Poisson, and then for the exponential distribution, we have a lambda of 4. And this is a good case for a business because customers arrive typically about every 8 minutes, and service usually only takes 4. But of course, there can be complications, and that's why there are other times beyond 4 and beyond 8. Or you could get lucky and it doesn't take as long, and that's why we have minutes 1 through 7. I'll go ahead and fill in the first probability calculation for Poisson in cell B7, so I'll type in equal sign. And my formula is Poisson.dist, and the x is in cell A7. I'm going to leave that as a relative reference so it can change when the formula is copied, then a comma. The mean is in B4. I do not want that to change, so I'll press F4 or Command T on the Mac, then a comma, and I do want the cumulative distribution function. So I will press Tab to accept true, right parentheses and enter. There's the lookup, and I will double-click the fill handle at the bottom of B7 after I selected the cell, and the formula copies down, and you can see the probabilities for getting a particular time or less. And the lookup functions that I use over here for interval uses B7, B8, B9, all the way down to B21 to look up a value and find an interval. So in the first case, the interval is 7, which means that the value was between 0.45 about and 0.31. Now we can do the same thing for the exponential distribution. I'll click in cell E7 and then equal, and then expon.dist. So we have our x again, that is in D7, again, leaving it relative so it will change, then a comma. The lambda is in cell E4, but remember for the exponential distribution, it is 1 divided by lambda. So 1 / and then E4. I don't want that reference to change, so F4, again, Command T on the Mac, comma, then true, right parentheses and enter. There we go. And I will click E7, double-click its fill handle, and there we have the values. And you can see over on the right that our service table has shown that we only have a total wait time, shown here in cell M22, of 2 minutes. That's pretty good. And if I look at the service times, I see that the largest one we have is 7, and the customer after that had to wait for 2 minutes, but that's the only time. But you can see here that we got lucky that we have fairly large intervals in column H and fairly small service times. We're not always going to be that lucky. So I'll press F9 to recalculate the workbook. This time we got 20 minutes of wait time, and you can see that we have a couple of cases with small intervals, and even though we only had one long service time at the top, in fact, it's the only one over 10, you can see how the backup went through the rest of the day. So it goes to show, and I'm sure that you have experienced this in your own life, that a small delay at the start of a day can lead to longer delays later. I hope you enjoyed this challenge, and please do look at the workings and formulas in this part of the worksheet. It's a good tool that you can use for a single service point to find wait time, service time, and arrival time.